motion. So basically what happens is you should have a reference point. Okay, reference point is very much essential, with the help of which you can align some other point. Let's say B. If this is point A, this is point B, and you are going from A to B. Okay, so basically with reference to some point only you can show that where you are going. Done. This is what is how you describe a given motion. Done. So what happens is we define it as the change in position with respect to time. Obviously, when you are changing your position, your time will also run. There is no work which has been done without time consumption. Done. So if the time is 0, that means you have not changed your position. And if you are changing your position, that directly conveys me that you have utilized some of the time. Making sense, Akshita?
Yes, ma'am.
Great. Fine. So this is how we define it. Now, inside motion, we have 6 patterns. Okay, that we have to study. Very first one is distance. And the second one is displacement. They are very much correlated with each other, and how they are correlated with each other, let me tell you that thing also. When you travel from one point to another point, you can take any of the given track. Okay, any of the track you can take. First track, second track, third track, fourth track. Okay, so at a given time, what exact path you are choosing to travel is known as distance. Understood?
Yes, ma'am.
The actual path traveled at a given point is known as distance. But the shortest path, if you have chosen, okay, that will be known as displacement.
Yes.
Making sense?
Yes.
Great. So if your distance is your displacement, that means you have chosen track 1. Because at a given time, you had chosen the straight track. So it will be a displacement. And you had gone through this track actually, therefore it is your distance also. Okay, so if the examiner is writing a small s everywhere in his or her equations given in the question demands, that means your distance and displacement at that point is same. Understood?
Yes,
Akshita? But if in case he is using some other track, he will give it to you that long track has been chosen, or a unorganized track is chosen, or a man walks a distance to this. Then you need to understand, okay, this is distance and this is different thing. Okay, but if he is applying both the thing at displacement only, that means he had chosen the shortest track only. Done? Any doubts still here?
No, ma'am.
Great. Now let's come to the next point, and that is scalar and vector quantity. Okay, so this we had discussed in the last class also, I guess. So what is scalar and what is vector? It's very much efficiently known to the 9th to 10th grade kid who is doing physics. Okay, those quantities which are having only the magnitude. Now what is magnitude? Yeah, magnitude means
just the
measuring
number. A number.
Okay, so for any physical quantity, suppose I have a physical quantity. What is a physical quantity? Those quantities which obeys the physics rule. Okay,
Yes.
like weight, like force. These are physical quantities. Like what is your height? These things. So when I say what is your height, you will say suppose 160 centimeters. So you had given me a number about it. Now the number obviously will be consisting of a number and its SI unit, because with the help of SI unit we come to know that what it is talking about.
Yes.
Done. It defines the physical quantity itself. Done. So if I am saying 160 centimeter, that means what? It is a magnitude of the height. Okay. But if I say that my weight is 60 kg, now weight is basically the force only with which the earth attracts you towards its center.
Yes, ma'am.
Okay. When you stand on the weighing machine, what happens is you stand over it and that is attracted towards the Earth's surface. Hence, due to Newton's third law, equal and opposite force, the same force Earth will apply over you.
Yes, ma'am.
Okay, there is a weighing machine. I'm standing over it and I'm applying a force at the Earth center. Then, so
Yes, ma'am.
same time the Earth will also apply the force over me, which is the normal force. Now, this weighing machine calculates this normal force and it tells you that your weight is 60 kg, 50 kg, 55 kg, like that. Understood?
Yes, ma'am.
So basically here, what do we convey? It's a type of force only, and as per the Newton's second law, F equals to ma. In the case of gravity, F equals to mg. So what do? We calculate the number of contents in our body and multiply it with the gravity of the earth. Hence we get the force.
Yes, ma'am.
Right? So the
Yes, ma'am.
weight is nothing but the force only. Now I got it. It is directed towards the center of the earth. So this direction conveys me that it is a vector quantity. Vector quantities are those quantities which have
Direction
magnitude,
applied.
yeah, plus direction. Okay. So in our syllabus, what we are doing study here, I should say that my distance does not have any fixed direction. You can change your direction anyhow in any condition. Okay. So that will be your actual path when you are traveling. So distance will be what? It will be a scalar quantity. Whereas displacement is a vector quantity because it is always traveling in a straight line from reference point to the target point. Understood?
Yes, ma'am.
Great. Now, obviously, we are dealing with two things, the distance traveled and the time taken. So, when you divide it with time, okay, you will get speed. So, this is the next quantity now, which is connected to distance. Similarly, with displacement, I can connect the next quantity, that displacement over time will be defined as your velocity. So this is the next quantity now which is connected with displacement. So this is my third quantity and this is my fourth quantity. Understood?
Yes.
First quantity was distance, second quantity was displacement, third is speed, fourth is velocity.
Velocity.
Speed is connected to distance, velocity is connected to displacement. Understood?
Yes, ma'am.
Great. So now here, velocity equals to displacement over time, Akshita. That means it is a vector quantity. Why? Because if any of the product of the formula is carrying a vector quantity, then the ultimate physical quantity also becomes vector in nature.
Yes,
Understood?
ma'am. Yes, ma'am.
Any doubts?
No, ma'am.
Great. So here in this product, I can see distance is also measured in meters, time is measured in seconds. So no particular direction is involved. Hence, this particular quantity will be known as scalar quantity. In displacement, direction is included. Hence, this particular quantity is known as a vector quantity. Understood?
Yes, ma'am.
I'm saying in the formula for the given physical quantity, if any of the product is a vector, then the ultimate physical quantity also becomes
Vector.
vector quantity. Understood?
Yes. Yes,
Yeah.
ma'am.
Great. So now let's move for the next quantity. And our fifth quantity is acceleration. And our sixth quantity is deceleration. Okay. We have reached from distance to distance over time. Now, this is giving you speed. Let's reach to the next point, that what is speed over time. So speed over time is nothing but your acceleration. Similarly here also, if I have speed over time, can increase, can decrease. So if it is increasing in nature, it will be known as acceleration. If it is decreasing in nature, It is deceleration.
Yes, ma'am.
Understood? Speed over
Yes, ma'am.
time when it is increasing. I'm increasing my speed when I'm going on a highway. So that is accelerator. I put my legs over accelerator. But when suppose I'm moving towards a rushed area, let's say market, then I will put my legs over the brake. That will decelerate my speed. Okay. How the acceleration is shown? Let's say my speed is 15 kilometer per hour. So this is acceleration.
Yes, ma'am.
Done. 15
Yes,
kilometer per hour square. Why square? Because two times speed is there, time is there. One time, two time. Done.
yes, ma'am.
So this is acceleration. But if suppose I'm decelerating, so you will just put a minus before the number. This will give a clear idea that the particular thing is decelerating in nature. Understood?
Yes, ma'am.
Minus gives me that the object is moving in the opposite direction. Obviously velocity can never you can move in the opposite direction like that. So what you do is you put a minus, that you show that now I am decreasing my speed. Clear? Akshita, please reply. Akshita, I'm waiting.
Hello, ma'am. Hello, ma'am.
Yeah, yeah, it's audible, it's audible now,
Yes,
don't worry.
yes, ma'am.
Okay, so now deceleration is the decreasing speed, that is what I had explained, right?
Yes, ma'am.
Done. So it is shown with the minus symbol. They can even write it retardation. Other than deceleration, the word they can use. Retardation can also be used. We just put a minus over it. Done.
Yes, ma'am.
And here we put a plus. That shows me it's an acceleration. Now, again, distance over time, as well as I had told you, when the distance and displacement both are the same things, that means I'm traveling a straight track only, then my distance and displacement will be same for a given track. So therefore, displacement over time is nothing but my acceleration, right?
Yes, ma'am.
Am I making sense? Yeah.
Yes,
Because distance and displacement can be same. Okay. It's never like they are different. They could be different, they could be same also. Because if I'm traveling the straight track only from one point to another point, obviously that will show me that I am traveling a displacement. And that is
yes,
the actual path I had traveled. So that will be my distance also.
yes, ma'am.
Done. So hence acceleration is calculated as vector quantity because it can act both speed over time or velocity over time.
Yes, ma'am.
Done?
Yes, ma'am.
Great. So it is also a vector quantity. Done? Now after this, we have the graphical representation. Let's move to the graphical representation now. Okay. Just do let me know if you want any topic to be repeated or in depth you want to do the study so that I can repeat that. Any doubts till now?
No, ma'am. Those are clear. Actually, I have more doubts in the graph part than the formula part.
Done. So check. If I have a distance time graph, okay, so this is
Yes,
my distance and this is my time. Always write the SI unit in brackets. It's essential in board exam. Done. So if you have this type of graph, this conveys me you are traveling equal distance in equal time, equal distance in equal time, equal distance in equal time. So this will be known as uniform motion graph, or you can also write it as, if I take this line, okay, so Akshita, what happens is here, this line is due to traveling y axis over x axis. This will give me the slope of this axis, that is theta angle.
yes,
Okay,
ma'am.
so the slope of this graph is y2 minus y1 over x2 minus x1, or I should say this is tan theta angle. What is tan theta? Perpendicular over base.
Yes, ma'am. Opposite.
So if
Adjust.
I do perpendicular over base, I will get this angle theta.
Yes, ma'am.
Okay, if I take out angle theta, I will be aware that how much slope it is producing from 0 to 90 degree.
Yes, ma'am.
Okay, now what is y2 minus y1? I guess this is s and this is t. So s of t is nothing but what? Speed.
Yes, ma'am.
And if distance and displacement are same, then even I can write it as velocity. Understood?
Yes, ma'am.
Okay, Akshita, now listen, very important. If examiner is giving you angle, you can find out tan theta. If examiner is not giving you angle, you can find out y2 minus y1. You have to choose y2 and y1, which is coming in more than half of the line. Please don't choose, suppose this is my graph, this is my line, and I had chosen this is y2 minus y1 and this is x2 minus x1. No, this is
Yes.
wrong. In IB board, this is completely wrong. You have to choose more than half of your graph. That means what? If my line is like this, you have to choose like this.
Yes,
More
ma'am.
than half of the graph. Okay. Now you do y2, y1, x2, x1. Now you will get the answer and hence you will get the speed of that graph. Making you understand clearly?
Yes, ma'am.
Great. Now let's move to what type of graph they will going to give you. So basically, how do they give? They will give you a graph like this. They will give you a graph like this. They will give you a graph like this. All our
Yes.
speed, right now we are discussing displacement time graph only. Okay.
Yes, ma'am.
Okay. So what happens is, if suppose my curved is going like this, then this is showing me a positive gradient. Positive. It is positive in nature.
Yes,
Done.
ma'am. Yes.
Positively increasing until a certain point, and after that it is gradually becomes the same.
Yes, ma'am.
Then here it is a negative graph. It is coming down. It is going up positive. It is coming down negative graph.
Yes, ma'am.
What is negative? Velocity. I told you that the slope of the graph gives you velocity. What graph? Displacement and time graph.
Yes, ma'am.
Clear?
Yes, ma'am.
Okay, sorry. So here the displacement is increasing. You can imagine that, right?
Yes,
As
ma'am.
per time, my displacement is increasing. Here my displacement is decreasing with time. Check. Isn't it?
Yes, ma'am.
So my displacement here is 2, 4, 6. So first it was 6, then it got 4, then it got 2. Okay. As the time is passing, it is decreasing in nature. Hence it's a negative graph. It's a deceleration graph. Understood? Whereas
Yes.
here the velocity is increasing in nature. So it is a positive graph. What happens to this graph? Let's look at this graph. So this is displacement. This is time.
I
So
think this one is rest. Is it
as
that?
rest. Yeah, it is at rest. Okay. Because the time is passing for this, but no change I can see on the y-axis. Hence no change in the displacement. Done?
Yes, ma'am.
Great. So this is how you will solve for displacement time graph. What type of conflictions you are facing? Let me tell you that. Suppose I'm throwing a ball and they had drawn the graph like this and then this. Obviously, the graph will be like this because it goes like this when you are throwing it up. When you are
Yes, ma'am.
throwing it up, okay,
Yes,
your
ma'am.
force is gradually decreasing and hence at a given point it will stop and then again it will come down.
Yes, ma'am.
Clear?
Yes, ma'am.
So above the ground, when anything is going up, suppose I'm considering the velocity, whatever is happening in upward direction will be always positive in nature. Whatever is coming down, whether it is displacement, whether it is velocity, whether it is time, whether it is acceleration due to gravity, whatever is there which is in the downward direction will always be calculated in negative symbol.
Yes, ma'am.
I will show you how. This is my ground. My ball is going up. So displacement is positive. It is going up. So the height is up. What is velocity? Let's talk about the velocity part now. So basically, just 1 second.
Yes, ma'am.
Hmm. Okay. Now, what I was telling is, sorry.
Yes,
Okay. What I was telling is, Akshita, that if suppose I am throwing something in the upward direction, that what I had told that it is covering a distance in the upward direction. Hence, the displacement will be positive in nature.
yes, ma'am.
Velocity is also positive in nature. Why? Velocity is going up. Okay. It is decreasing. While it is going up, it is decreasing. Hence, it stops at a given point. But velocity is going up from the ground. Hence, you will take it positive. Let's talk about G. G will be negative. G always acts in the downward direction towards the Earth center. Am I making sense?
Yes, ma'am.
Great. So if it is coming down, all the time it will be negative. Correct? Time is always positive. Time can never be negative. So this is what the quantities we have studied.
Yes, ma'am.
Great. So that means when I draw the graph of displacement and time, that I will show it as that if suppose this is time, this is displacement, it is gradually decreasing with
Yes, ma'am.
time. Displacement covered is gradually decreasing, velocity is decreasing, and then it will become negative because it will go up. Now it starts coming down. When it is coming down, what is happening? Now my displacement is in negative nature. Why? Because it is coming towards the ground. So when anything is coming towards the ground, it becomes negative in nature, isn't it?
Yes, ma'am.
When the ball is coming down, the displacement it is covering now will become negative.
Yes, ma'am.
This
Because
is
of
what I had told you, right? Yeah.
yes,
The rule is when anything is going up, it is positive. When anything is acting down, it is always negative from the ground surface.
yes, ma'am.
Making sense? Hence, they will give you this type of graph. They will ask you what distance it had covered, what velocity it had covered. So you take this distance, add this distance, you will get the answer. What displacement it had covered. You take this displacement, subtract this displacement, you will get the answer.
Yes, ma'am.
Making sense?
Yes, ma'am.
Yeah. So you have to read the graph in such a way that your concepts should be clear, then it will not bother you for any given graph. Sometimes they will give you like this: a girl is sliding, it stopped, then it came back. Sometimes they will give you a graph like this: it traveled like this, it gone like this, it traveled like this, it gone like this. Okay,
Yes,
so how you will find out? How you will find out the things? So basically, what you have to do, where it is at rest, so it is at rest at this point. It is at rest at this point. So they will give you the points A, B, C, D, E. Okay, where the object is at rest. So between DE, between BC, where the object is performing velocity in a positive direction, or where the acceleration is happening. So you will write here between
Yes.
C and D and A, because it is going up, it is catching up the speed.
Yes, ma'am.
Understood?
Yes, ma'am.
Yeah. So you need to align your things in such a way that you are able to. Now you tell me what are your doubts in graph.
Usually, ma'am, in the graphs, like always, like, can I write in the board, ma'am? Can I draw the
Yeah,
graph?
sure. Yeah.
Something,
Draw it and show it to me.
uh,
Hmm.
it kind of like is curved, like
Hmm.
it's like usually curved, ma'am, but downwards. Kind of like I don't
Hmm.
remember, ma'am. I was doing one of the questions in the past paper. I don't know which past paper it is.
Okay, you do one thing when we have the next class, no, Akshita, it's okay. It's okay. Not an issue. When we have the next class, na,
Yes,
till that time, you do one thing. You send your questions to Miss Sonia and she
yes,
will pass it to me. Done?
yes, ma'am.
Okay. When she pass it to me, I'll go through them, and whenever we are having the next class, that is tomorrow, I will start my day with that questions. Done?
Yes, ma'am.
But you send your questions in prior so that if any query is there which needs to be recognized, I would be able to know about it prior. Otherwise, what will happen? We will be able to run with a short of time.
Yes, ma'am.
Understood? So you send me
Yes,
your graphical questions and Miss Sonia will convey that to me, and accordingly I'll work over it and I'll explain it to you. Done? That how do you deal with those graph also.
yes, ma'am.
Okay? No issue.
Yes,
No issue if you are having doubts. Okay, now let's talk about velocity time graph also at the same time. Okay? Because
yes,
right now we had discussed about displacement time graph. Let's talk about velocity time graph. What happens here is, hmm, okay. Suppose this is my velocity time graph. Okay. So the very basic thing I should tell you, it is the acceleration. The slope is the acceleration, first thing. Because again, y2 minus y1 over x2 minus x1 will going to give me, this is velocity, this is time. Hence the formula for velocity over time is acceleration. So it will going to give me acceleration. Understood?
yes,
Or
yes,
even if you are solving for tan theta, that is this one is theta, it will going to give me the acceleration of the graph. Done. Now next thing in velocity time graph which is very important is the graph, the area which is considered inside velocity time gives me distance traveled by the object. Understood? The
yes,
distance traveled by the object, the area will give me that thing. Okay,
yes, ma'am.
Akshita?
Yes, ma'am.
Okay. I had explained you two things very important. Slope of velocity time graph gives me acceleration of the
Accelerate.
graph. And the area inside the graph gives me the distance traveled by the object.
Yes,
Okay.
yes, ma'am.
Examiner will confuse you by giving a graph of object is falling freely falling towards earth. Okay. And he will give you a kind of graph like this. That object is falling and it performs a graph like this.
Yes, ma'am.
Clear? Now you
Yes,
tell me how much distance it had covered. So you divided it into two shapes. This is my square, I guess. Even if it is a rectangle, you can know it by calculating y2, y1 and x2, x1, correct?
yes, ma'am.
You find out the formula for square. For square, it is side into side. For rectangle, it is length into breadth. You can apply any of them.
Yes, ma'am.
Also here I am having a trapezium. So what is the area of trapezium? It says me that you take the height, multiply with the addition of the parallel sides, let's say parallel 1 plus parallel 2, and you have to multiply the thorough thing with half. Okay. So there
Yes,
are certain formulas which define us that what do we do. Now you add both of them. You will get the total height which is covered, the
yes, ma'am.
distance which is covered by the object. Understood? Any doubts?
I just like I always have this doubt, ma'am. Like, can you go to the last graph which you drew? Uh, yes, ma'am. Is it possible if somehow if I don't remember this equation in the exam,
Areas. The formula of areas, right?
possible if we again divide this and make this a rectangle and this a triangle?
Yeah, sure, sure. This is up to you how creative you are to design your areas. It's just you have to add all the areas perfectly.
Yes, ma'am.
No issue if you are dividing it in square and trapezium or rectangle and a triangle. It's literally your creativity. That half into base into height is easy for you. You do that. Nobody is stopping you.
Yes, ma'am.
Done?
Yes,
Ultimately, you are calculating the area, whatever the formula you are applying.
yes, ma'am.
Making you understand very well?
Yes, ma'am.
Okay. Any other questions?
No, ma'am.
Great. Now we have two things over here, and that is what is average and what is wait. Okay. What is average and instantaneous velocity? Let me give you a clear idea about this also. So when we calculate the average, it's simply the change in average velocity I'm talking about. Okay.
Yes, ma'am.
What is average velocity? So what you have to do, the total distance you are having, the total displacement over total time you will get an average of.
Yes, ma'am.
Understood? What is
Yes,
instantaneous velocity? Instantaneous velocity, the velocity at that given moment. It means that, like I'll give you example. You had traveled, let's say, for 10 minutes. And I'm asking you, Akshita, where were you at 6th minute, 6th second? So you will try to recall that point.
yes,
So
ma'am.
that instance, what I have talking about is your instantaneous velocity.
Yes, ma'am.
That I was at this particular point and I had calculated it like that. So how you will going to do that? You will going to do that by using differentiation method. You have studied in maths?
Yes, ma'am.
Okay, great. So that means when you define your instantaneous velocity, if it has been asked, okay, otherwise it's not always the chance that they will ask you this, but if it has been asked, you should be aware of the formula. You will write ds. How you are
Yes,
writing? Ds by dt, na?
yes, ma'am.
You are using ds in maths. Very good. So ds over dt. Done?
Yes, yes, ma'am.
You will use this formula for instantaneous. You will use this formula for average.
Yes,
Average you understood? During the
yes,
thorough journey, what is your average speed? Somewhere it was 60, somewhere it was 70, somewhere it was 85, somewhere it was 90. So what was your average speed? So you will try, you will say, ma'am, average, on an average, I was traveling near around 70. Okay. So you had done a calculation of the thorough thing and then you had divided it with the thorough time and then you got the average time of average speed of that. Done.
yes, ma'am.
Okay. Now, after this, we have one more type of velocity, which is known as uniform and non-uniform. I hope you are aware of this.
Yes, ma'am.
Okay. Tell me if you are not aware.
Uniform velocity is when the velocity is of the same, like when the motion is, uh, like, how do I say this?
It's
Same.
okay. I will explain.
The
No issue.
movement is like, when the time period and the distance is like this, equal thing, equal interval of
Yeah.
something like that.
Yeah. Very good. So basically, what happens when you travel equal distance in equal interval of time?
Yes, ma'am.
Okay. This is known as uniform motion. When you travel equal equal distance in equal interval of time. When you travel unequal distance in equal interval of time, okay, the term is equal distance. If it is speed they are asking, you will use distance. If they are asking velocity, you will use the word displacement. Understood?
Yes, ma'am.
Okay. Equal distance and equal interval of time. Done?
Yes, ma'am.
Okay. Here, unequal distance in equal interval of time again. Your time is an independent quantity, hence you measure every time within given time. Okay, the time period should be fixed for you. Like I am measuring for kilometers per hour. So per hour is my fixed thing. If I'm measuring meter per second, so my per second is fixed. So time will be always equal, whereas the distance that you have traveled will be equal and unequal as per the uniform and non-uniform graph respectively. Understood, Akshita?
Yes, ma'am.
Any doubts?
No, ma'am.
Sure.
Yes, ma'am. For the graph,
Great.
how does the rest and the normal for uniform velocity, how
Okay,
does
this is the uniform graph. This is the uniform graph.
and how
And
the
this is the non.
rest represented for uniform velocity, ma'am?
Uniform velocity at rest. Why
Yes.
uniform velocity will never go at rest, bache?
Yes, ma'am.
Rest
I
means distance is zero traveled.
yes. Is
Velocity
it
is distance
possible?
traveled.
Is it
Distance.
possible to have a graph like that?
No.
Okay.
What happens is when you are at rest, the distance traveled becomes zero. Okay. And
Yes.
velocity itself conveys me that it is distance over time. So when the
Yes.
numerator is zero, you will get zero answer.
Yes, ma'am.
Am I making sense?
Yes, ma'am. But the confused us to like
Sure.
kind of like give the graph, which kind
Hmm.
of is similar to the rest, and so I kind of get confused with rest and the uniform motion.
Yeah. No issue, no issue. Perfectly fine. I'll explain you that. Okay. Now let's come to the next topic, and that is projectile motion. Okay. Any confusion till here,
No,
Akshita?
ma'am.
Convey.
No,
Sure.
no. Sure, ma'am.
Chapter is clear to you.
Yes, ma'am.
If you want to ask anything, again, I had told you with related to this chapter, go through your past year papers, HL. Okay. You can take out the questions and you can send them to Miss Sonia. Okay.
Yes, ma'am.
Done. And we will solve them. Now, let's move to the next point, and that is your projectile motion. Listen what happens. When the motion is not horizontal, neither it is vertical, but it is in between. It is known as projectile motion.
Yes,
That
ma'am.
means it is covering both horizontal as well as vertical. Right? It is covering this range also, it is covering this range also. I hope I am making you understand well.
Yes, ma'am.
Okay. And in simple language, we say when any object is performing a motion at oblique angle. Oblique angle means the angle which is nor 0, neither it is 90.
Yes, ma'am.
Okay. It is some other angle in between of it. So we say at any oblique angle if it is performed. Okay.
Yes, ma'am.
Done. So this is projectile motion. Now pay attention. If suppose this is the initial velocity u with which the object is traveling, done. It had reached the highest height point. Let's say this. Let's say it is h, and the horizontal range it had covered. Let's say it is r.
Yes, ma'am.
Great. So my u will get covered in two things: vertical and horizontal. This is my vertical. Sorry, This is my horizontal, this is my vertical. Done. So by
Yes.
calculating this and this, applying Pythagoras theorem, I can take out my hypotenuse.
Yes, ma'am.
Correct.
Yes, ma'am.
Vectors have the specialty that they can shift from their positions without changing their magnitude and their direction.
Yes, ma'am.
I'll explain you this. Just give me a sec. I'll explain you this. Uh, just give me 1 second. Can I come?
Yes, ma'am.
Yeah, just give me 1 second. Okay, yeah. Hi, Akshita. I'm back.
Yes, ma'am.
Yeah. So let's continue. During the first half, that is from point A to B, and the second half B to C. Then in first half, the velocity of the object gradually decreases as it catches the height. Why? Because at the same time G is trying to pull it down. So the force of gravity acts or counteracts for the upward force, making you sensible.
Yes, ma'am.
Done. So let's say here the speed is 4 meter per second. So here it will be 3 meter per second. Here it will be 2 meter per second. Here it will be 1 meter per second. So ultimately here it will be 0. It will
Yes,
take
ma'am.
a gap of just 1 microsecond nearby, and then it will starts to come down. Again it will cover the same pace that it had covered in the first half. Okay. So here the fact is the object will try to get increasing velocity. Why? Because here the G is counteracting it, but here the G is adding it. Velocity is also coming down and the G is also acting downward. In this case, the velocity was upward. In this case, the velocity is downward.
Yes, ma'am.
So both will add up in the same direction and they will cancel in the opposite direction.
Yes, ma'am.
Correct? V is due to the mechanical force with which the player is throwing the ball. So the
Yes, ma'am.
mechanical force is counteracted by the gravitational force. Done. Now, hence,
Yes,
here the velocity gradually increases 1 meter per second, 2 meter per second, 3 meter per second, and here it will be 4 meter per second. Clear?
yes, ma'am.
Great. Now, it attempts two type of velocity. Let me tell you that also. Okay. So, what type of velocity does it attempt? When it goes like this, it attempts u here. Here it becomes the theta angle, you must have studied in the vectors that the theta line, okay, the theta line basically is the cos line. Do you know this
Yes,
how and why?
because this is cos, that is sine. Like I don't remember why is it that, and the other one is 1.
Other one is sine theta. Let me tell you how and why. Suppose this is my vector. Okay, this is my vector. Parallel shift means you can shift it over here. You can shift it over
Yes,
here.
ma'am.
You can
Yes,
shift
ma'am.
it over here. Condition
Yes,
applied is you cannot change its magnitude and direction. This is
yes,
magnitude and this is the direction. Okay. So you
yes,
cannot change the two, but you can change its position anywhere. Understood? Second thing, if this is my velocity, this is my base, this is my perpendicular. Let's change my perpendicular over here. Okay. Try to
yes, ma'am.
understand. If this is angle theta, what is my sine theta is? Sine theta is hypotenuse, perpendicular and base. Sine theta is perpendicular over hypotenuse.
Yes, ma'am.
Hmm. So that conveys to me that my perpendicular, the value of perpendicular is sine theta into h.
Yes, ma'am.
H I had told you is u. So it will be u sine theta. So that means my perpendicular value is u sine theta. Got it?
Yes, ma'am.
Let's talk about the base part now. So my cos theta angle is base over hypotenuse.
Yes,
So
ma'am.
what is the value of base? H into cos
H.
theta. This will come over here, right?
Yes, ma'am.
What is the value of h? V cos theta. So this is what I had written here.
Yes, ma'am.
Understood how we are giving it the names? Any doubts?
No, ma'am. What about
Sure.
if there V sine theta? Uh,
Sorry.
we have found U sine U cos.
And u cos theta. Yeah.
Do we have V sine theta?
Yeah, you can write it as v sine theta also. No issue in that. V is final velocity, u is initial velocity. When it reaches here, you will get v sine theta, v cos theta.
Oh, okay, ma'am.
Right? Yeah.
And
So
yes,
let's
ma'am.
talk about this. This is my h point, height. This is my capital R. Okay. And
Yes,
here I got u cos theta. It will have two components now. One is the horizontal component, one is the vertical component. Okay. Let's talk about the horizontal component. I think the distance is the range, whereas in vertical, the distance is the height. Correct?
yes, ma'am.
Great. Let's talk about the velocity. Here, horizontal, it is u cos theta. In vertical, u as u sine theta. Correct?
Yes, ma'am.
Great. Now, acceleration. So, acceleration in horizontal direction is always zero because it is acting towards downward direction, not horizontally. Correct?
Yes, ma'am.
Hmm. And here, the y direction, it is g.
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 Yes,
Acceleration is G, no? When you throw the ball,
yes,
acceleration
ma'am.
due to gravity works. And due to that, it's going like that. Right?
Yes, yes, ma'am. Yes, ma'am.
Then we have the velocity. Let's talk about the velocity. So throughout this range, the velocity is constant. Just remember this point. Throughout horizontal, it is constant. It never changes. Whereas for vertical motion, it first decreases in this first half, A to B, right?
Yes, ma'am.
And then from B to C, it starts increasing.
Yes, ma'am.
At the highest point, it is zero.
Yes,
Make sense?
yes, ma'am. Makes sense.
Okay. Anything you would like to ask out of it?
So the uh ve- vertical uh vertical displacement is 0, and then the highest point.
Vertical displacement is not, vertical displacement is h. Vertical velocity 0 is at highest point, I'm saying.
Vertical velocity.
Yeah, it becomes 0 when it reaches here. Here the velocity is 0 because g is
Yes,
maximum.
yes, ma'am.
Now it will try to pull it down.
Okay.
Correct?
Yes.
Right? Yeah. Anything else?
No, ma'am.
Sure.
Yes. How do we derive the formulas, ma'am?
Yeah, I'm deriving that, but just you are, if you are comfortable this thorough drawing, then I'm clearing it.
1 second, ma'am.
Hmm. It's okay. You can draw it afterwards. Let me finish it. It's okay.
Yes.
Are you drawing it?
I was drawing it. Is there, are these not saved, ma'am?
Nah, this thing has been recorded, so you can see it afterwards also.
Okay.
Okay. Yeah.
Yes.
Let's move for the next part, and that is time of flight. Very first one is time of flight. Done. Now, what is time of flight? It is denoted with capital T. Let's talk about it. I am considering vertical motion in this, and in the first half, I am considering that is from A to B. Okay, done.
Yes.
So
Yes.
in A to B, my vertical velocity was u sine theta, correct?
Yes, ma'am.
Done. And let's consider that in the first half, the time period is t. In the second half, again, the same time is taken. So time period is small t. For the whole, it is a capital T time of flight, which is known as 2t. Understood?
Yes, ma'am.
Great. So now I have u sine theta. My acceleration was minus g. Vertical motion I had considered.
Yes,
So
ma'am.
vertically small g was working, right? Also
Yes.
my time period I have to sort. Done. What is my final velocity vertically? At B
Final
point it was
velocity
0.
0.
Yeah, A to B. So V, Y, I should say it is 0. Clear?
Yes.
Let's apply the formula. V equals to U plus AT. So V is 0. U is U sine theta. Plus A is minus G into T. Correct?
Yes, ma'am.
So that means GT equals to U sine theta.
Yes, ma'am.
Great. So time period formula is U sine theta over G. The total time of flight is 2t, hence it will be 2u sine theta over g. Clear?
Yes. Yes, ma'am.
Any doubts?
No, ma'am.
This is for the first half. You add the second half, you will get 2t sine theta. Done?
Yes, ma'am.
Clear?
Yes, ma'am.
Let's calculate for now. Uh, what is remaining now? I think height formula also it is coming in your exam, right?
Yes, ma'am.
So let's calculate maximum height. In height also we can take the same things, that is vertical motion only, because vertically you are having the height, right? Let's consider from A to B again the same thing. Okay, so here again uy is your u sine theta. Okay, and your vy is 0 again. Okay, acceleration is again minus g. Done. Your displacement is your height. Anything you would like to ask?
No, ma'am.
Let's apply the formula now. Formula connecting this is v square equals to u square plus 2as.
Yes, ma'am.
Correct? Done. So this will be 0. This will be u square sine square theta. This will be minus 2gh. A is minus g, s is h.
Yes, ma'am.
So 2gh equals to u square sine square theta. H will be u square sine square theta over 2g. Understood?
Yes, ma'am.
Making sense?
Yes, ma'am.
So this is the formula for height. Understood? How you will recognize that which formula you have to apply in exam. When the angles are given, Akshita, you will apply projectile motion formulas. When the angles are not given, Akshita, you will simply apply the u square v square 2s. You will not use any of this situation. Until and unless theta is not given, you will not use this equation. If theta is given in the question, you will use this equation. Otherwise, simply use this and you will get the answers.
Yes, ma'am.
Clear? We have
Yes, ma'am.
Newton's
Oh,
equation. Three equations. Yes,
what
say.
if we need to find the theta, ma'am? In case if they ask us to first find the
Oh, so you
theta,
just
then we just use the Pythagoras theorem.
tan theta formula. Remember? Tan theta slope.
Yes, ma'am.
I explained you this
Yes,
in the
ma'am.
start. That you will use.
Same. Okay.
Perpendicular over base. Done? Okay. Now last point is your horizontal range. Okay. Let's come to this point. What is horizontal range? Which is capital R. So we will complete here the horizontal motion. Okay. That is from where to where? Horizontal
From
motion, that is from A to C, I guess.
yes, ma'am.
A to C, because we have to find the range. Okay. Let's consider A to C. I am considering. Okay. Now let's consider this. My ux is u cos theta in this case. Acceleration is 0. In horizontal motion, acceleration is 0 because it is acting only vertically.
Yes, ma'am.
Velocity is constant u cos theta throughout the system because acceleration is 0.
Yes, ma'am.
Horizontally. Okay. So
Okay.
vertically the speed is 0 at the highest point, but horizontally the speed is there. U cos theta. That is why it comes down. It never
Oh,
stops over there.
yes, ma'am.
Then after this we have the range which we are covering it like R. Done.
Yes, ma'am.
Great. Now apply this formula. I think my time period also I have calculated, and that was 2u sine theta over g. Correct?
Yes, ma'am.
Done. Now let's apply this one. So I will consider a formula connecting all these terms. So it will be s equals to ut plus half at square. Okay. Let's apply. So s is nothing but r over here, and r here it will be u cos theta. Done.
Yes, ma'am.
What is t value? I think it is u sine theta over g. Correct?
Yes, ma'am.
Minus half g. For a, I will apply g. So I think a is 0. So this term will completely become 0. Right?
Yes, ma'am.
Correct?
Yes,
So
ma'am.
that means it will be minus 0. Correct?
Yes, ma'am.
So I got the formula for r, that is u square sine theta cos theta over g. Clear?
Yes, ma'am.
Okay. Anything you would like to ask?
No, ma'am. For
Sure.
yes, ma'am. For like in exam, ma'am, during the exam, each time instead of
Hmm.
deriving it, we can just memorize this and use this, right? If
Yeah. Wait, let me
we
check.
have to solve it.
The T. Wait, Akshata. This
Yes.
time period is for the whole range. So I guess it will be 2u sine theta. So here 2 will also be added. Sorry. Okay. For the whole range, you have to use, no?
Yes, ma'am.
Half was only u sine theta, but the full was 2u sine theta. Done. So here u square 2 sine theta cos theta. You can use only the formulas in exam.
Yes, ma'am.
Okay. So this is it for the day. Okay, Akshita. The chapter is over. If you have any doubt, you can convey that to Miss Sonia and she will convey that to me. Okay?
Okay, ma'am.
Okay, done. So, Akshita, bye for now. If you have any doubts, just do let me know. Okay?
Yes, ma'am. Yes, ma'am.
Bye, Akshita.
Bye, ma'am. Thank you, ma'am.
Yeah.